Okay, in this problem, we're looking at the limit as x approaches -3 of this expression right here. Notice that involves a sum of two radicals here in the numerator. And I know what you're thinking. You're thinking, well, I see a square root plus another square root. I'm going to have to multiply by a conjugate to figure this limit out. But hold your horses. If you just blindly start multiplying by the square root of -x minus the square root of x plus 6 in the top and the bottom, you're going to cause yourself a lot more work than you really need to do. Look, the first thing you should consider in trying to evaluate any limit like this is, does this expression here represent a continuous function at x equals -3? Okay? And barring piecewise defined functions or other kind of strange things, a lot of times we can tell that just by trying to plug in -3. Looking at what is the limiting value of the top, what is the limiting value of the bottom. Okay? And so if we do that, if we make that calculation, we can see that we're going to get square root of 3 here, right? -3 plus square root of 3 again, -3 plus 6, all of that over 3 squared, or 9 minus 9. The bottom, of course, has a limiting value of 0. The top, of course, looks like its limit is 2 root 3. Look, this is enough to figure out what the limit is doing overall. The denominator is getting very, very small. The numerator is getting closer and closer to 2 root 3. As you divide by smaller and smaller quantities in the bottom, this whole thing gets larger and larger. Now, whether or not this thing is large and positive or large and negative remains to be seen, but we can certainly say that the limit does not exist. Okay? Both the left and right limits here, again, we haven't figured out what they're doing in terms of positive or negative, but both the right and left limits are going to be infinite because of this extraordinarily small thing in the denominator and the fact that this numerator is not going to 0. We also know, because of the presence of these limits which will tend towards infinity on the left and right hand side of -3, that the graphical interpretation of what's going on here is some sort of vertical asymptote at -3. The question is, what is the behavior of the function as we approach from the left? Does it fly up to positive infinity? Does it fly down to negative infinity? And what's the behavior of the function as we move in from the right? Does it go off to positive infinity or down to negative infinity? And that question can be resolved by looking at the individual one-side limits. Both the limit as x approaches -3 from the left of this expression and the limit as x approaches -3 from the right of this expression. Okay? So going back up here, notice again as x approaches -3 from the left, and it's a good idea to get a representative value in your head for this. What's just left of -3? Maybe -3.001, right? We're farther left on the number line. So if I plug that in, the top, again, just like up here, is going to be very, very close to 2 root 3. Okay? And whether or not we're below 2 root 3 or above 2 root 3 doesn't affect the sign of our expression. It's still going to be positive. But look what happens down here below. We have something, again, like -3.001 squared. That's going to be bigger than 9, minus 9. This whole thing is certainly going to be small, as this predicted, but notice the x squared here, bigger than 9, minus 9, that results in a positive small thing. Okay, so again, in the top, something very close to 2 root 3, in the bottom, something positive always, and getting exceedingly small. Of course, we know just by, like we did here, that this thing is going to get infinitely large. But notice the sign here, positive over positive. That's going to be tending towards positive infinity. Okay, so we can write that in. And the corresponding behavior over here on the graph, as we approach -3 from the left, so we're coming in from this direction, the function in terms of its height, this function right here, in terms of its height, should be flying off to positive infinity. In other words, some sort of behavior like this. Okay? Now, what about this guy over here? As we approach -3 from the right-hand side, again, the top is going to be getting very, very close to 2 root 3. Whether we're a little bit above that or a little bit below that doesn't really matter, because the sine of something above or below 2 root 3 is still positive. However, on the bottom, because we're approaching 0, I need to know what side of 0 I'm on. It affects the sign. Okay? So we've got something close to 2 root 3 on the top. In the bottom, plug in something just to the right of negative 3, like negative 2.99. That's going to be something smaller than 9. You're subtracting 9 from that. That's going to be a negative value. Okay, and again, this denominator is just getting smaller and smaller the closer we get to negative 3, so this whole fraction is getting larger and larger, right? How many small things can you take out of 2 root 3? And if these are smaller, you can take out even more still. Okay, so again, we have infinite behavior, and notice the sign. Numerator is positive, denominator is negative, so this must be negative infinity. Okay, and again, the corresponding behavior over here on the graph as we come in from the right, as we approach negative 3 from the right, our function's height should be tending towards this. It should be flying down. Okay, so now we have a very clear picture of what is happening to this function. Y equals square root of negative x plus square root of x plus 6, all that over x squared minus 9, right around negative 3. But our initial answer here to our question is our limit does not exist. Okay, that's it.